Dear students, in this video we are going to discuss about Newton's third law of motion, which says that to every action there is equal and opposite reaction. Okay, which means if there are two bodies like A and B, and these two bodies are interacting with each other, such that if body A is applying some force on body B, then the body B will apply the same amount of force on body A, but in opposite direction. I repeat, there are two bodies of unequal masses. Okay, they are different bodies, of course. If one of them is applying a force on body B, on the other body, then the other body would in turn apply the same amount of force on the first body. So this is Newton's third law. To verify it, to understand this, I'll suggest you to do an activity. You can keep the heavier book on your hand. You can rest it like this. Some heavier book, really heavier book. So what will happen, you will see that your hands will struggle hard to balance that book over them. So that means if you have kept a book over your hand, the book is applying a weight. Weight is a force. That force which is acting vertically downwards. Like I am holding a book, the weight of the book is a force, and that force is acting vertically downwards. So your hands will apply a force, an invisible force, to support that book, isn't it? So the weight of the book, or the force applied by the book, is known as action, and your hands are giving you a reactional force. That's why it is said to every action there is equal and opposite reaction. Since they both are equal, that's why your hand is pretty well managing to balance that book over it, isn't it? So according to this law, forces exist in pairs. Okay, they never exist alone. And one more thing, though the forces are equal when the two bodies are interacting, but it doesn't mean that acceleration is also equal. Okay, as an example, if body A is applying a force over body B and body B is applying a force over body A, so they should be accelerated by the same amount? No, because force is equal to mass into acceleration. Acceleration is equal to force upon mass. More the mass, more the denominator, and lesser the acceleration. Lesser the mass, lesser the denominator, and more will be the acceleration. You know, you must have heard that the tides go up because of the gravitational pull of moon, isn't it? But when something is applying force over the other body will also apply the force over the first body. But we always see the tides rising up and not the moon falling down. The reason being the size. Okay, the size depends, size actually determines the acceleration, how much a particular thing will be accelerated. So of course there's no doubt about that. To every action there is equal and opposite reaction, but accelerations are not same. तो हमें ऐसा लगता है कि one object तो बहुत ज़्यादा move कर रहा है and the second one is not moving at all. Okay, like Earth is binding you with its gravitational attraction, you know that. Okay, otherwise you all would be flying. Earth is binding you with its gravitational attraction, but again the same thing, Newton said that to every action there is equal and opposite reaction. So if the Earth is attracting you because of its gravitational pull, so you must also be attracting Earth, but we see your attraction and not Earth's attraction. We see that if I am going to drop a pen, it's going to fall down, but I am not seeing Earth falling down. Why? Again the same thing, forces सेम है, लेकिन एक्सीलरेशन सेम नहीं होगा. Reason being masses, difference of masses. Since Earth is so massive than you or any other pen, pencil or any other object, so that's why we often see the acceleration of pen or pencil or any other object and not of Earth. Try to get it. Fine. So there's one more example that I'll be discussing over here. This is a table and a book is kept over a table. Now this particular book is applying a force over the table. Okay, so table must also be providing a reactional force.